Yeah, that was a good time. Yeah.
You know what? Just let me have my
We're like 3 hours into the egg drop thing that we were supposed to do, and I still haven't.
I'm up on the board.
We should, yeah, bring it in sometime.
No one could beat my record.
Okay.
I did so many things, and then I am the ultimate champ.
Chapter 5. Get out your summaries, please. I'm going to grab those from you.
I could have made my egg drop project lighter. You put stars on these.
Did I not put one on the last one?
I don't know. I'll just yes, please. I did it. Is green okay? I don't care. Chapter 2. I don't have a star. Thank you. There you go.
Inspector Gadget says he'll go
Have we only done one other summary? Oh, chapter 4 we haven't had it now. We skipped one.
now like
We skipped 3. We skipped 3. We did. But we haven't got 4. Yeah, because I did color, pencil.
Just put it in the bottom right tray.
Oh, you gave us stars on this one.
Okay, so we got the question out there. Which is greater, static friction or kinetic friction?
Kinetic friction is a little
If they are
bigger.
In other words,
From
If
my
it's
nose, it's a
moving.
little bit bigger.
they're equal. If it's not moving, it's technically
okay.
kinetic is only
It's just on the
So they're-
sliding, not bigger.
Basically, the real question is, what does it take more force to get something moving or to keep it moving?
To get something more.
Yeah, to get something moving. Static friction is the larger number, and it always will be.
It's technically only equal to the force that you apply on it.
Exactly.
So, technically it's a trick question.
Not really, because your force of static friction, by definition, is going to be like how much friction it can withstand before it starts moving.
So
Like if
it's
you're not putting
automatically
enough
the
on,
max.
what's it?
It's automatically the max static friction.
In general, yeah, but of course if I'm putting, if I put 10 newtons of force on this, that is the force of static friction for this particular scenario. The main thing you gotta kind of think about for this one is if we have a graph, we got force of friction over here, and we've got applied force over here. As you put more and more effort into this, if the object is not moving, you'll eventually reach a point where the object does start to move. When that happens, the amount of force that you have to put on in order to keep the object going is going to be less. So this would be like your maximum amount of static friction. Kinetic friction, or regular friction, as I usually just mention it, is going to be much, much lower. Not much, but it's going to be significantly lower. So this would be what happens for static friction. This is what happens for kinetic friction.
Friction or static friction?
Yes.
Oh, I thought.
So yeah, does that make sense then?
Yep.
Good. Takes more force. What's that?
No, I was thinking it was kinetic or static friction and just kinetic force.
Yeah,
Oh no.
because it would technically only be they would be opposite forces because static friction is when it's not moving and kinetic is when
Right.
it's moving. So that's why I was confused. That's why it was a trick question.
Oh,
And maybe we talk about potential force and potential friction.
Are you all okay?
No.
I'm glad I wasn't the only one.
No, you weren't the only one. I went to chapter 4 when we did
I wasn't smart enough to process the question either way.
It's all good. The main thing is that you have it so that you're set for the final.
Yeah,
Okay.
so
So,
We're gonna fail that too.
in terms of these objects, in terms of the objects and their motion, your force of static friction is always going to be equal to the coefficient of static friction times normal force. So if you're not moving, this is the equation you'll be looking at. If you are moving, this is what you're looking at. So your equation for force of friction is the same. The only difference is your little coefficient of friction is different based on whether you're moving or not moving. All right, guys, time to come back to the table here.
I have the table.
So, yeah, this is our force of friction. And the main thing we got to do in this particular chapter is to do everything we did in the last chapter, but now we get to add our friend friction. And that's what the main thing is today.
It's all fun and games until I bring a pen and write neglect friction in there.
Everybody give me a section. I want attention.
So,
I'm so
Assume friction.
I appreciate the math of not doing friction, but in my mind I hate not neglecting it because I know it's there and it
Girls on
makes
the live stream, cover your ears and sharpening our pencil.
All right, you're going to want to put this picture in your notes.
Nope, sorry.
Yeah.
What if I don't want to?
Then you'll fail.
And that's too bad.
I mean, I guess I will.
Mr. Hathaway was just so honest and I was just like,
Mr. Hathaway, have you ever heard me like angry?
I don't think I would know if you were angry, Placido. I'd just be like, is he kidding? I wonder.
I'm always kidding.
Really, though?
I don't know.
No one knows what's Placido. Not even myself.
sounds very smooth.
What gets you mad, Placido?
Systemic racism.
Okay, that's noble. So this is the information we know.
Okay, go ahead. I'm doing it.
So this is our setup. We've dealt with this time and time again in the last chapter, but we've never dealt with it with friction. So let's do that.
So it's the same thing, you just add friction.
Yeah, basically.
This makes this chapter sound easy, actually.
Yeah, and tomorrow we do circular motion. That's where it gets a little bit more difficult. The other thing about this chapter is oftentimes they ask you to keep things in terms of letters instead of numbers.
yeah, I don't like that.
So this one will be fun and games. The next one is one where we mostly just deal with the symbols and the letters and things.
No, thank you.
So hold on to your seats for that.
Disgusting. I'm disgusted.
And honestly, you guys could probably do this yourself. If you want to try this, go right ahead. I'm just going to walk through it on the board.
Not saying I don't.
No. So I'm going to deal with the 4 kilogram mass first.
You always need extra credit.
Mr. Hathaway?
Yeah.
What specifically are we trying to find?
So usually with these problems, just like the ones in the last chapter, you'll have to try and solve for acceleration. And oftentimes they'll just start by asking tension force. But you're not going to be able to solve for tension force without an acceleration. So these are the two things we're going to try and tackle. So 4 kilogram mass. I don't care about the vertical forces. They don't matter here because it's not moving that way. It's moving horizontally. So those are the forces I want to consider for my 4 kilogram mass. It's got a tension force. That comes first because it's winning. It's moving to the left. So tension force comes first in that equation. I'm going to shift it.
My homies love tension force.
What's that? Is that friction?
Friction comes next.
No.
All my homies hate friction.
Right.
Totes.
I only
So-
put friction. I refuse to put friction anywhere but third.
Questions on where this equation comes from?
No.
Good. So next thing, I'll just isolate the tension force. And like always, just let me know if I mess something up, please.
How can we know if you mess something?
We're big right now.
Okay,
Yeah.
we got that.
Wait, you don't subtract.
No
You don't
problem there.
subtract.
Oh yeah, there we go.
See, look, we got you.
Good.
That's how we subtract.
Mr. Hathaway, we got you.
Or maybe for my pluses, I just don't cross them until I'm done with everything.
Yeah,
Why would you do that to
yourself? That's
You know how I would remember that 2 negatives made a positive? It was because like you have 2 lines. Yeah.
Nice. Yeah, that makes sense.
My brain works. I still say that. Yeah, I do too.
7 kilogram mass.
My brain doesn't
So it's
understand
minus-
everything until the day of the test. and I-
Let me know if I make any mistakes here.
Always gonna purposely make a mistake. Oh, that was supposed to be a T.
You guys are on something else right now. I'm on
My
TikTok.
brain is on something else.
G7.
My brain is still thinking about what we just learned.
The gravity of the 7-pound mass.
What did
Well,
we
I
Seven
mean, like,
pounds.
G stands for also for G7.
What?
Like a G. So
Isn't gravity
Are you
what?
feeling
Yes, thank you.
I was about to say.
Do not forget when you're writing these equations, it is imperative that whichever force is winning comes first in your force equation. So,
I knew that. I was like, it's so wrong.
Sorry. Yep. So gravity has to come first here. Tension comes second. Because it's going down, gravity's winning.
Why is like a G such a wicked
Alright, I think I did that, right?
Yes.
Okay. So now, we gotta combine these two things together and see where that leads us. Hopefully it leads us to an acceleration and a tension force.
Hello? Would you like something?
Now, force of friction again is mu times normal force. And in this case, because we're on a flat surface, nothing's pulling up or pushing down, normal force is just equal to mg. And force of gravity is just mass times g. And we got a fancy looking equation there. So from here, we want to get that acceleration out so that there's only one a. So the next step on that is pulling this m7a to the left, and then I'm going to take my friction expression and toss it over to the right. Because once I get the a's on the same side, I can factor them out. Yeah.
I like when it gets like all simple.
I know, right? Wait till you see the next one. The next question looks like super complicated. And by the end, it's like you cross just everything out. And you're left with one little thing.
It's like how
That's like at math when they make
Where
you
was
solve
it?
derivatives the long way, and all of a sudden everything just gets simplified out, and it's just like
Yeah. How long did it take for them to teach you the quick way?
Like a day.
2
no,
weeks.
2 weeks.
2 weeks?
2
Okay.
weeks.
Thank you, Mr. Mason.
Really?
Hey yo, shout out to
I
Mr.
must
Mason
have not
for
been
watching
paying
this. I
attention.
hated how you teach derivatives.
Mr. Hathaway's a real one. He taught the shortcut right away.
See, I just don't pay attention to math, so.
Long way
I pay attention, and then I'll look down at my paper for like 3 seconds, and I look up, and we're on like I don't even know.
So you're like on number 1, 2 plus
You go
2,
from
and then he has like
concavity to
linear.
linearization.
I understand what we're doing.
This stuff is fun.
Fun.
Yeah.
Girly.
Fun is not the word I would use.
Why not? It is fun, is it not?
Fun complaining
No.
about it.
What class? Calc. Calc is fun. Yeah.
Katie.
Your
girly.
calc class is fun.
Your definition
No,
of fun.
AB is the worst. AB is the worst.
It's because we have all the girls in there.
No, they're girls. Who just-
No, we have all the bottoms in there.
all the girls.
Wow.
Am I wrong,
This
Katie?
is why AB is the worst.
They have
Class it up, and they need some explanation of what you just said.
All right. I'll give you an explanation. We got the 7 kilograms. We got 9.8 meters per second squared.
You tell me.
0.3 is unitless because it's coefficient of friction. 4 kilograms, 9.8 meters per second squared. Kilograms on the bottom.
Is that friction?
Any question
Is that
on
symbol of friction?
this fancy looking thing?
No.
Is that symbol of friction?
Which one? This one?
Yeah.
You?
Yes, that's coefficient of
Hold
friction.
on, Mr. Hathaway.
Well, can I just write F?
Yes.
Would G be 9.8 or negative 9.8?
9.8. Excellent question. In the force section, G is always regular 9.8. The reason for that is because when you're doing stuff like this, you know, your force equation for this is tension force, well, in our case, it's gravity, minus tension force, and this subtraction takes that negative gravity into account. So we don't have to...
Do you have the answer?
I do.
Is it 5.17?
5.17 meters per second squared is absolutely correct.
I don't trust myself to get here by myself.
Right.
So, in order to finish this thing off, you take that acceleration and you either plug it in here or you plug it in there. And you can just finish.
Mr. Hathaway.
Yeah.
On the ACT, what did you get on the science section?
Oh, I don't even know.
You got like a 2 or
The
something.
science section sucks on the ACT because
Yeah,
it's not really
thank
science.
you.
Everybody hates the science section.
You're just looking at graphs, more math than
The
anything.
science section. All my hail means
No,
I hate the
Dude,
science
it's like a
section.
reading section.
All my hail means.
It's more math
Oh.
than anything else.
I actually, I think science is my best section on it, and I don't understand why, because it's mainly reading. No, that's bad, because I should have gotten my best as math, because I'm a math person.
Oh, I see.
And I'm a math science person, but the science section is mainly reading.
Mm-hmm. And you're not very good at reading, is
I'm
that?
awful at English.
Okay.
I got 26.
Girl, I
All
hate
fun.
this
Yeah.
section. The reading section can go. Do not like
Connor, but you speak another language, so
Where is my
That doesn't change anything.
Oh, do I not have my
yeah, but you're way more impressive because you speak 2 languages.
I only got 6 in the race.
So what?
I can barely speak one.
My friend got a 7.
Doesn't change it.
Yeah.
The folks at home can see this.
Well, I looked at it
Yeah,
and
well
I was
enough.
about to say, never mind those
Right.
miles. But no, I got this.
I'm like, it's just numbers. Like, why is it so hard for people to grasp?
still the same
this
problem,
whole
right?
Like, I pushed the desk.
No, we're doing a different one now.
How do I
Why did
get rid of that?
We did?
Well, we actually knew the coefficient of friction.
One step below.
I want to listen.
Yep, so that one was given to us for a change.
I'm listening to our people on that.
Yo, I'm pretty sure the next calculator up is ACT and SAT band because it's basically Google. Ooh.
Ultra high heels.
I'm not gonna go over there.
I'm sorry.
Is this a new example?
This is a new problem.
Do you think I need a new sheet of paper? Will it take up over
Ooh, that's a, no, it'd probably take up less, depending on how big you make the picture.
One can say she likes to live dangerously.
So,
Thank you.
are they all going to be this easiest chapter? Or are
No.
they going to add in a force?
Now,
Will it get harder?
you'll kind of see. No, this is as hard as those get.
Oh,
Okay,
First of all,
really?
there's
So
the mouse.
just switching out the whatever
The mouse.
force pushing it.
Also,
Yeah.
here,
I'm gonna let
go
you
to
shut
the
this
page.
one.
Have a look at the page.
Well, there's like 3-4 days of notes in this chapter, so
Is that a lot?
we'll see if you like it by the end.
Yeah.
How many
Wait,
days
what?
do we have left?
I
We have a
made
Mythbusters
Just
day.
one or
You
two.
can also hook it up to your computer and
Did we do the
download
Mythbusters Day already? Because there's only one for this force whole thing.
But I don't.
Oh, well, we had one last
Yeah.
Isn't that
2 weeks
crazy?
ago.
Okay, then we probably did that already. We'll see.
Mythbusters Day are like a study hall, a learning day, and a graders day. It's like a just day.
It's like a magical
These are
thing.
perfect.
Yeah, mental health day.
So the previous example was an example of kinetic friction, or regular just friction. An object is moving and there's something going against it. Now we're going to use an example of static friction. Now you're going to love this question.
I'm
Here's
sure we will.
here's the goal. I actually have to look at it. Solve
Who can erase it the fastest?
solve for the coefficient of static friction as a function
As Ben solves it in his head.
of theta c, and that means critical angle.
He needs to stop.
So,
Yeah, I'm done.
Okay.
Thank you.
Okay, that's done.
And this is.
Trevor has
So it's a lot of
idea.
variables.
Yeah.
Yeah, a good amount.
Trevor's the only one
There's
who never
no
got
numbers.
confused in this class.
Not yet.
That's the point.
So here's the thing then. I'm not going to give you the mass. I'm not going to give you anything. I'm not even going to give you the angle. But the purpose of this problem is to just kind of show you and make sure that you're okay following how we can do these problems without numbers. Because it's the sort of thing you do have to get comfortable with, whether you like it or not. So
What's the safe word, Mr. Hathaway?
the safe word, never mind.
Mark
I was
Never mind.
thinking of something funny and I don't know how it would
I
have
was thinking of Mark
So-
Capone, and I have no idea why.
Mark the dump truck is now the safe word.
come. So,
For the dump truck.
If I'm shouting Martha dump truck during a test, just
how am I supposed to keep going with this?
I don't know. Now you got wheezy.
Thou shalt not throw thy pencils.
All right. So, we've got our mass right here. It is not moving, so that's at least the good part.
Say Mr. Dump Truck. What does that say?
Mr. Dump Truck.
No, Mark the dump.
Okay. We've
Well, there
got
goes my mental health. It's literally on a slope going down.
gravity going down.
It's not moving.
Oh yeah, it's not moving.
Wait, I'm gonna do this all by myself.
Thank God.
We've got normal force going up. Now, even though this looks super complicated, this problem and all problems that look like it, usually you go about solving them in the exact same way as you've done in the past, even if it's asking for something all funky like this. And you'll see that we have to do the same process no matter what. It's just we're going to end up with a result that is a little unusual without numbers. So this is what we know. Normal force going up. There's gravity going down. Because it's holding still, there is some friction going to the left. And this is kind of our raw force diagram there. So, if we want to go anywhere with this, I got to figure out where this angle's going to go. And remember, in regular physics, when we're trying to figure out angles with this kind of a picture, we want to start with a little dotted horizontal line somewhere. And actually, before we even jump into those angles, what do we got to do with our axes?
Rotate them.
Yeah, we got to rotate those axes.
No,
So-
it takes
Normal force will always line up with your y-axis. The surface itself will always line up with your x-axis,
Can we call it y prime and x prime?
if you want to. So then we have to realize force of gravity is actually broken up into two different directions. It's partially going in the x direction. We call this FGX. And it's partially going in the y direction. Let's call that FGY.
So it's the coefficient of friction. And it's
I'm calling this Fenn interpretation.
So now we can put those angles in. So where is this angle going to go? Is it going to go to the left or to the right?
Left.
It's going to go to the left.
To the left, to the left, to the left.
So that's my critical angle there. This here I'll just call phi. It's not. I need everything in terms of this critical angle. So when I'm dealing with my triangles, I always want to deal with the one that actually has that critical angle in it, i.e. this guy.
That's why
Wait,
you have
why is that
sine and cosine. That would
Comment.
Why is it that one? I thought it was one to slide the triangle.
Yep, we'll get to that. Sure. You're up, Katie.
Bye, Katie.
Bye.
Wait, where are you gonna be for Leeds tonight?
She's just getting secretary work.
So, actually,
She's not a lead.
those of you at home, I hope can see that. I'll try and hold it still if you need to. This is an interesting school year. Okay.
Did she tell you how to do secretary work?
Yeah, so pause that if you're at home and have not been able to really see or read that yet. Okay. So to answer Jaden's question about usually it's the angle at which you would slide it right in, that's exactly what we're doing. We're taking this triangle, we're sliding it in right here. You know, you'd slide it in from that side. Yep. So now we can actually do some math here and hopefully go somewhere with this. And sometimes with these problems, that's how you start them. You just look at what you know and put it in some kind of force equation and hope it goes somewhere. That's how I'm going to approach this. Let's hope that it actually works out. Because I mean, this is what it's all about. You know things vertically. You know things in the x direction. We should be able to get somewhere with that. So let's look at the x direction first. What color should I use?
Hold all four of them in a straight line like this and just write like.
That's awesome.
That gets so.
That'd be so hard.
I
In order to try and go somewhere, then let's look at what's going on in the x
This is
direction.
what we learned last chapter.
Yeah, it's the same stuff. It's just being more comfortable as it asks for more complicated answers. In the x direction, we've got gravity and we've got friction. So our equation is going to look like this. Now you might be asking, Mr. Hathaway, isn't gravity negative? And here's the answer. Whenever you have gravity and friction together, gravity is always the positive one. Friction is always your negative value. Always, always, always. This trumps even gravity. So, if that's my equation, you can kind of see where I'm going to go with this. So, force of gravity in the x direction is equal to force of static friction. And my hope is that somehow I'm going to get an expression of static friction from here so that I can get my answer.
Wait, I thought you said friction trumps gravity.
Yeah, it does. Friction is always negative. Always, always, always. Even though it seems like gravity should be negative.
Oh.
So if you have to choose, like usually they're both negative, but if you have to choose between the two because they're opposing each other, you want to make friction the negative one. So force of gravity in the x direction. Now, usually, I like to take this and do the cosine of whatever angle this is. But this is not the critical angle, so I'm not going to do that here.
So then you take the sine of the critical angle?
I'm going to realize that this force of gravity in the x direction there is equal to this down here. So I'm going to use the sine of this triangle. So FG times the sine of the critical angle. And because this equals force of static friction, that means FG sine critical angle is equal to, what's the equation for force of static friction?
Mu force.
Yep. So, we're kind of at a solution, sorta. I mean, we're relating the critical angle and the coefficient of static friction. And that's good. But this question is really trying to ask for these two things sort of by themselves. There's a lot of clutter here. We got gravity, we've got normal force. If there is some way that we can take this maybe one step further and see if we can get an even nicer looking answer, that would be great. If we can't, this would be a fine answer. This relates coefficient of static friction and critical angle. Yes?
Oh, I was just gonna say
Do we have to do y then?
Yes, we're going to look at the y direction. Yes?
Would you use cosine critical angle to find normal force?
Yes. Yep. So now we got to look in the y direction. Exactly. We're going to use a different color. What color?
Black.
Black?
So
Okay.
why isn't that answer given?
Because
It's technically a function of
it
static
is. But if we can make this, if we can boil this down to something simpler looking, like maybe just critical angle and just coefficient of static
Oh, so
friction, that would be
So
ideal.
you just want it like basically a ratio.
Yeah. And let's see if that happens. So, in the y direction, we've got normal force. We've got gravity in the y direction, and that all equals 0 because it ain't moving. So, normal force equals gravity in the y direction. And let's see here. Gravity in the y direction is equal to,
FG.
yep, so that means my normal force is equal to Fg cosine theta c. So look at this. I can make my normal force more specific. I'll take this and I'll throw it in there. And this is where it gets good.
I was like, cancel.
Oh yeah, that's the best part. So let's be more specific now. Force of gravity is mg. So we've got mg times. Okay. I made a shoe mark that looks like a tornado. It's awesome. So, this is great because look at all this stuff that can go away. The M's go away. The G's go away. And oh my goodness, I've got a sine and a cosine. Can I do something with those?
Make it a tangent.
Yeah, tangent never gets any love in this class. So this is a nice change. Coefficient of static friction is equal to sine over cosine. In other words, tangent of your critical angle.
Is that always the answer?
Actually, it is.
So we can just memorize that.
Memorize the answer.
Well, this is the only time you'll have to prove it. You'll be using this in other things where you actually have to do some work. But yeah, and just to make sure that you know what this means in the real world, what this means is that if I take something that won't cost me anything if I break it. All right. That means if I take the scissors
The skizzers.
and I get to the angle at which coefficient of static friction is overcome, the angle's growing, the angle's growing, the angle's
Surprisingly long.
right here. If you take the tangent of this angle, that is equal to your coefficient of static friction. That's where that number comes from.
That's kind of cool.
I know, right?
Appreciate that.
Okay, you know what? That is kind of cool. I'm not even gonna lie to you.
Otherwise, I'm just gonna ask myself.
And I
why
would be
you-
like,
Yeah. Because, I mean, this whole thing, coefficient of static friction, it's like, what the heck does that mean anyway? It's a unitless quantity. Who really cares? But yeah, as that angle grows and grows, when you get to the point at which that object will start sliding, that you take the tangent of it, and that's equal to your coefficient of static friction. And of course, that number is different based on the two different surfaces. So there's a whole slew of coefficient of static friction between rubber and concrete, and between ice and
that
salt
one
and everything.
Where it was like steel on steel. And,
Yeah.
Okay.
That's cool.
Now, this is fine for, and we finished it. That's great. Any questions on this before I just take one more small step?
What's some
I get it. I just can't do it by myself.
Gotcha.
Yeah.
Dude,
As long as-
I feel about this entire stuff.
Yes, Placia.
If you're solving for critical angle, could you say u cotangent equals critical angle? U over tangent equals critical.
Oh, I suppose. Yeah, that's it flipped. Yep. So, again, all we did is stuff that we learned last year. This is not anything new. And it was reviewed in the last chapter, which is good.
Technically, yeah, we have home goals already.
Yeah. So here's the thing, too, then.
Yeah, you right,
Or
man.
2 years
But who remembers?
I could have solved
We did
I
solve
actually learned it.
We talked about coefficient of static friction and what it means in the real world. What would I do in this little experiment to figure out what the coefficient of regular friction is? Anybody know?
Or you need the time.
Nope, you don't need a time. So I know the angle at which it begins slipping. If I take the tangent of it, that is the coefficient of static friction. In order to get the coefficient of kinetic friction, you got to find the angle at which it will go down at a constant speed. So whatever angle that is, you take the tangent of it, and you get your coefficient of regular friction. So that also has
So
meaning.
would that also be the like minimal angle because it would be like.
Now, because notice, watch this. When I finally get to the angle at which it moves, it's speeding up. So it's going to be an angle that's a little bit less, and that's why your coefficient of friction is always a little bit less, as opposed to the coefficient of static friction.
Yeah.
Yep.
And now that is the T.
So you have to try to start and then
You'd have to just find the angle and just try and get it moving and see, you know.
slow it down.
Yeah, you'd have to get a
Or
range
have
and
a
stuff.
Really long plane.
Mm-hmm. Now I got one more step I just want to mention with this. So,
Identifies an airplane that has constant rates of static friction.
what's that?
I'm an airplane that has constant rates of static friction.
So your airplane
Yes, you are.
or your static friction is 0, therefore you have touch force.
So, when you're driving, how many of you guys have something hanging from your rear view mirror?
Well,
We all
have
should, because
that
we have the more
stupid
moving
part of
Martin Luther
it.
Right.
King.
I know. That's so hard, yours. You know what?
Sure.
I don't have a car. Fine.
So if you've got something hanging from your rearview mirror, like maybe it'll be your tassels when you graduate. That's what mine was for a while. And after that, I hung a little parachute guy. So as you pick up speed and you slow down, that's going to change in angle. You know. So if you're, let me use green. If you're on the road and this is a side view, and this is whatever's hanging from your rearview mirror, maybe it's.
I learned this on PBS.
Oh, you did?
There was like a rough
Whoa,
dog
whoa,
show,
whoa,
and
whoa, whoa,
there's one question.
That's what I probably shouldn't put personal.
Put a shoe or something.
Okay. I can't draw. I only can draw like stick people.
We
Where's my
understand that it wasn't. Yeah, and a shoelace.
What if it is a shoelace and the other one is
Oh, well done.
wow.
So-
Ah.
This incredibly long shoelace and this incredibly small shoe then is hanging from your rearview mirror. And eventually, let's say you're at rest and you just gas it and this thing really, really goes up there. And you can actually, figure out what angle that is. Now, here's the interesting thing. All you need, this is the best part about physics, is knowing this stuff. All you need to figure out your acceleration is this angle. I could do the proof with you, and it would take another 20 minutes, like this. But if you take the tangent of this angle and you multiply it by 9.8 by g, that is equal to your acceleration.
He's so proud.
You don't need any stopwatches. You don't need any meter sticks. You don't need anything. You just need this angle. Take the tangent, multiply it by 9.8, and that's equal to your acceleration. I think that's pretty awesome.
What's that thing called that takes angles, like the little plastic thingy?
Oh yeah, that's true.
Protractor. You just need a protractor.
All
Yep.
you need in life is a protractor.
A lot of life problems could probably be solved by a protractor.
I killed my car in the middle of the street when I was
seriously,
driving
how's
to
that?
school today. I had to turn my hazards on.
In case you haven't seen.
I really thought I was thinking about a protractor.
There we go.
That's
Yeah,
cool
I
enough.
killed my car, so I brought my
So
protractor.
we're done today with all this.
Yes, we are finished today.
Oh, we're talking about protractors. Way to bring the group down.
Yeah, I'm the weak link.